Hello everyone, welcome to this session. Today we will discuss about the conversion of coordinate systems. Myself, Dr. Sohail Rana from Sasi Institute of Technology, Tadepalligudem. So here we will begin with the relation between various coordinate systems. We have studied three types of coordinate systems: cylindrical, spherical, and Cartesian. And frequently we need to convert point from one type of coordinate system to another type of coordinate system. So we have also seen how to define point P in various 3D systems, that is nothing but the coordinate systems. Here we can see one highly projected animated 3D axis where point P is defined, and we can see various parameters. R is the radius, Z is the height, this rho is distance from z axis, theta is horizontal angle, phi is vertical angle. So we have to find out what are the different conversion methods between different coordinate systems. So we can see conversion of spherical coordinate to rectangular coordinate. So what we have to check, radius rho or r are shown in the figure. It is for a cylinder and it starts at z axis. This rho starts at z axis and radius r is given for sphere and it begins at the origin. This is the basic difference between the radius of cylindrical coordinate system and radius of spherical coordinate system. Both are radius, but in spherical it starts from origin, say r, and calculation of radius starts from z axis if we consider cylindrical coordinate system. So for this diagram, if we apply trigonometric rules, we can have rho by r equal to opposite by hypotenuse, which is equal to sine of phi. There is a basic relation using which we can derive further relation between the convergence of different coordinate systems. So from that we can say that rho is equal to r sine phi. In few books this angle may be given as theta. So from the geometry of figure we can say x is equal to r rho cos theta and y is equal to rho sine theta. Z is unchanged. Height z is same. So keeping value of rho from this equation 1, we will get x equal to r sine phi cos theta. If we keep here, we will get y is equal to r sine phi sine theta and z is as it is. So from the same figure we can also say that cos of phi is equal to adjacent side by hypotenuse, which will be equal to z by r. So from here we can say z is equal to r cos phi. So here what we are doing, x, y and z are the components of Cartesian coordinate system. Say x is Cartesian coordinate system, y is Cartesian coordinate system, z is also Cartesian coordinate system. And what we are doing, we are converting them into in the form of r, phi and theta. That is nothing but conversion for spherical coordinate system. So this is what we do in conversion. So by using geometry of figure we can find out the various relations. Like here we can see where point P is showing the relation for conversion. Say we have r theta phi or r phi theta, point P defined in spherical coordinate system. So from here we can get the height z. Z of Cartesian coordinate system we can represent by r cos phi. In few books it will be given as theta, so we can write r cos theta. Similarly, we can have different conversions. So for example, here we can see here this radius on the ground. Here for this plane z is equal to 0. So that's why in equation there is no zero term. We have root x square plus y square. But when we see the overall radius from the origin, which is extending with some height, it has all three components, x, y and z. So it can be given as square root of x square plus y square plus z square. So this is rho in spherical. It is same as Cartesian. Now here we can see these are the relation point P we can define in Cartesian as well as conversion into spherical. Let us move to next. Say we have r is equal to square root of x square plus y square plus z square. Now theta, how we will calculate theta? It is y by x with by side. So tan theta is y by x. So theta will be equal to tan inverse of y by x. So from here we can also get conversion of theta. Therefore theta is represented in form of y and x. So for calculation of phi, we can have cos phi is equal to z by rho. So phi will be equal to cos inverse of z by rho, where rho is nothing but square root of x square plus y square plus z square. So this is for the calculation of phi. Now we'll see conversion between cylindrical and Cartesian coordinate system. Similar way, similar diagram we can use to represent them. So what we will get here, we will get, say we have Cartesian components x, y, z and cylindrical components, say r, theta, z. So here in few books it is given as phi also. So we can write r, phi, z. Depend upon the example, you can use the angle name as phi or theta. So how can equations are given? Say x will be equal to r cos theta. So x of Cartesian coordinate system we are converting to cylindrical coordinate system. Then y is equal to r sin theta and z is unchanged. It is same. Height in Cartesian coordinate system and height in spherical cylindrical coordinate system is same. And r square we can write as x square plus y square. So from here we can say r is equal to square root of x square plus y square. So we have already seen in the 3D diagram. So this is r. So from here tan theta is equal to y by x. So theta will be equal to tan inverse of y by x. And z is as it is, unchanged. So one more diagram we can see how we get this diagram. Say this is y and this is x, two-dimensional diagram. Point P we are representing on the ground floor, where on this ground what is the value of z? Z is equal to 0. This is the top view, you can say. This is the top view of our 3D system. So our 3D system is like this. So here we have this plane. This is the plane which is represented from top view. So here we have y, distance y, this is distance x, this is angle theta and this is radius r. So Pythagorean theorem provides equation. From Pythagorean theorem what we can say, this r square is equal to x square plus y square. So hence r will be equal to square root of x square plus y square. So from here we can also say that x is equal to r cos theta, y is equal to r sin theta and tan theta is equal to y by x. So from Pythagorean theorem we can remember these equations for the conversion. So it is very easy method to remember the conversions. In examples we use these conversion methods. So one more thing what we require in the example solving is the direction. Direction, components, dot product. So here we have conversion for these three components. These three components are AR cap, A theta cap and AZ cap. And it's these directions for the Cartesian coordinate system are AX cap, AY cap and AZ cap. So if we take dot product of AX and AR cap, then we get answer as cos theta. If we take product of AX cap and A theta cap, we get minus sin theta. If we take AX cap, AZ cap, we get answer as 0. Third one, AY cap, dot product with AR cap, sin theta. AY, A theta will give cos theta. AY, AZ will give 0. Then AZ cap with AR cap will give 0. With theta also it will give 0. But dot product of similar unit vector is always 1. So this we have to remember. Dot product of similar unit directions is always 1. So this is about conversion. So we will see one example. The example 1. So example is convert following vectors to cylindrical coordinate system at the given point. So here we have two examples. First one, we have to represent phi AX cap at point P, where rho is 4, theta is 120 and z is equal to minus 1. Second one, phi x cap at Q point, another point Q is given at x equal to 3, y equal to 4 and z equal to minus 1. And third one, have three components, 4ax cap minus 2ay cap minus 4az cap at point P where x is 2, y is 3 and z is 5. So let us see the solution. So first one we will see where point P is at phi x cap. So this one we have to represent with in terms of r, theta and z. So we have already seen, so point P component of radius rho. So here we have the vector, magnitude and direction. So this is the magnitude phi x cap and this is the direction AR cap. So this one is equal to cos theta as per our table of dot product. So this dot product will give output as cos theta. Just now we have seen in the table. So from here table what we get? We get cos theta. So here we have cos theta. Similarly, this for PR. So here we can take for P theta. For P theta we have magnitude, direction. Again this dot product will give minus sin theta. So here we got minus phi sin theta. And similarly PZ. PZ is Z is same. But dot product of AX cap and AZ cap will lead to 0. So this term will not participate in the point P conversion. So what will be the point P? It is combination of say phi here, phi cos theta. Direction is AR cap minus phi sin theta, A theta cap. So that is the conversion solution. Now second part, for point Q. For point Q, theta is equal to tan inverse y by x. So y by x is 4 by 3. So if we solve this, we get 53.13 degrees. So point P at Q, it will be phi cos, we'll keep the value of theta, then minus sin value of theta. So after solving this, we get 3 AR cap minus 4 A theta cap. One, where vector B bar is defined as in terms of x, y and z. So we have to convert it into in terms of r, theta and z. So first step for r component the magnitude into AR cap. So now we will take product with each one. So what you will get? So this one product with this one minus 2 product with this one. So AX cap dot AR cap, we get 2AY cap dot AR cap, AZ cap dot AR cap. So from our table of conversion we get BR is equal to 4 cos theta minus 2 sin theta. This is about BR. Similarly, we can calculate B theta. So B theta is equal to A theta cap equal to magnitude into A theta. Now one by one we will take dot product of A theta with all the three. So after simplifying we will get it minus sin theta minus 2 cos theta. Then third one BZ magnitude into AZ. So again we'll simplify it and we'll get minus 4. So all together we'll write total B bar will be addition of AR component, A theta component and AZ component. So again we can keep the value of theta. How to calculate theta? This value theta we have to keep. So theta is equal to tan inverse y by x. Y is 3, x is 2, we get 56.31. So after keeping these values, we get answer as 0.55 AR cap minus 4.43 A theta cap minus AZ cap. So this is a simple way of converting the coordinate system. So we'll close this session with the quote of Einstein. Thank you. Have a good day.